Sorry for the small delay. We're now continuing with the next talk, which is spinning static instrumentation for binary reverse engineering by David Gulian-Fandos. So please.
Yeah, more or less. Okay, so thank you for being here. It's weird to have two speeches at the same time. So thank you for choosing my speech. As I already said, I'm David. I'm from Spain, so sorry for my English. You know what happens in Spain. I don't usually work in security because I work in completely unrelated stuff. I work at a big semiconductor company, so I don't usually do this kind of speeches. So I would say that this is my second time. So forget me if you don't understand me. It happens a lot. Oops. What did I say? It's in German. I don't understand what. No. Okay. So I'm talking. How do you hide this? Do you know? Oops. Go out. Go out. What the heck? Ah, it's okay. Ah, thank you. I'll just use the arrow keys. I don't want to break the computer. It's a Windows computer, so it's highly likely. So I'm going to talk about a little bit about reverse engineering because I like lower stuff. I mean, low-level stuff. So maybe a lot of you already know what reverse engineering is, but in case you know, I will explain it briefly. So reverse engineering is well, some people might say it is an art, but it's like a technique or a lot of proceedings that you can follow in order to discover how a software program works and figure out what it does. So basically, you get an executable. You don't have the source code. You don't have any clue of what it does. Well, sometimes you have some kind of clue, and you have to understand what it does and how is it doing that. So it usually you usually use a disassembler, which you know what a disassembler is, and a debugger in order to support you in this research. So far, nothing new here. I mean, many of us have done this. Oh, sorry, that is a PDF, so it was meant to have some kind of animation, but anyway. So maybe you know these programs here. This is IDA Pro. The other one is Oli DVG, and this is Insight, which are typical debuggers used by hackers in order to disassembly and patch software. So the question is, sounds easy, right? No, in fact, it isn't. Basically, debugging an application, especially a big one, a huge one, is boring. I mean, you can spend whole nights like I do, but it's really, really boring. So as I'm a lazy guy, and I said, okay, I want to figure out a way so I don't have to spend so much time in order to disassemble a program. And how can I do that? I mean, I prefer to spend some weeks working on a tool and using that tool instead of just reversing by hand any single program. So in the past, I never seen this because I'm not that old, but many people told me that in the past, people actually wrote their own assembly source, and they wrote assembly programs. So you could more or less open a program, disassemble it, and read the assembly, and it used to make sense. I mean, you had like counters, loops, conditions, and it was like a human-readable source. But now that doesn't happen anymore because we use compilers, and compilers are highly optimized. Well, they say they are highly optimized pieces of software, which take your C or C++ or whatever shitty language are you using, and convert that to a binary, already compiled machine code. So this is not good for us because we have trouble in order to understand what the compiler is doing. Many of you have seen some demo of disassembly, and maybe you can find like 3 or 4 or sometimes 10 versions of the same function, and the compiler decides, okay, I'm going to do a special version of this function when the first parameter is constant, or when the second parameter is between this range of values, so it can accelerate the execution of that application. But it has a good thing using compilers, is that they are really predictable, well, more or less, and they respect calling conventions and any communication interfaces. This is good because we know that if we create a program or a DLL or any kind of binary, the interface between those binaries is going to be stable in the sense that they will talk the same language and they know how to talk to each other. And that's good because we can read the binary specification and say, okay, this guy is passing the parameters using the stack. This other guy is using this register to indicate that. And that's good because we know that things that are constant over time are easy to reverse. So the question was, why I can use this kind of information in order to do something like automatic reverse engineering? Well, this is a big thing. I'm not so bold to pretend to do completely automatic reverse engineering. That would be crazy, but well, let's try at least. So the idea is let the machine do all work or almost all work. So do you think it's even possible to do automatic reverse engineering? You know, you have to write some kind of source software which gets your idea and tries to reverse the program. You know what happens with machines? Machines are stupid. Well, as stupid as the guy who codes or programs them. So the question is, can we replace a human or 99% of a human by using software? And I think that the answer is yes. I mean, nowadays, a lot of people are doing software, which in the future, or maybe right now, they can replace most of people working in some places. So let's create a tool. That was my idea. I want to create a tool which does all the dirty job I don't want to do, and it serves me the good stuff, so I can look at it. I can look at the meat of the thing and say, oh, this is the thing I wanted to find. This is the instruction I have to patch. This is the function I wanted to really look at it. The other ones, I don't want to spend my 3 weeks or 4 months looking in that source. And in order to do so, I thought, what technique can I use? I mean, how to do that? And the answer, it came clear to me, was binary instrumentation. Well, the reason is that I usually work with binary instrumentation at work, and it was a thing that I already know. And I don't think it has been used, well, more recently it has been started introducing in the hacking world, but in the past, binary instrumentation was not used in hacking stuff. Well, I think. I don't know all the projects in the world, but so far what I've seen. So what's binary instrumentation? No. So binary instrumentation is a technique. It's not really modern technique, but it has been being used for many years. But it's a technique which allows us to get an executable and modify this executable so we can do a lot of nice stuff with these modifications. For example, we can modify the behavior of the program at runtime. So we get the executable, we add some stuff there, and we can force the executable to behave in a different way that it usually behaves. But it's typically used in an, let's say, non-intrusive way. So we modify the executable, we take a look at some stuff in there, and we extract some conclusions and some information out of the binary, or of the software. And it works at assembly level. So it basically picks the executable, disassembles it, and starts doing stuff with the disassembly itself. There are a lot of tools. Maybe the most famous one is Spin, is Intel's tool. But there are also free alternatives like Dynamorio or Valgrind. Valgrind it's really used in Unix environment for catch simulation. For example, it is also used for checking whether you are overrunning some buffers. This is called memory tainting. So you'll find a lot of Google results if you Google for Valgrind. So how the thing works? Here I have a small example. What the thing is doing is in black. Well, the color is not much noticeable, but there's a black source code and the red, which are the call functions. So what it does is it gets the actual disassembly and starts reading the disassembly and understanding, of course, it. And in this example, I told, well, this is a synthetic example, so I wrote it by hand. And I told the tool, every single time the machine, the CPU, is storing some data in memory, okay, it's doing a write to the memory, I want you to notify me. And what it does is it finds every single instruction which does this. In this case, would be the movie 80 RCX. and this other one, the movie Eddie RCX +4, and it injects a call instruction before. Well, you can choose if you want to do it before or after. Sometimes you want to do both, just to look what it's about to do and look what happened after it did something. So basically, it has to write source code on demand. So it gets the executable, it modifies it, but it has to do that under demand. I mean, during runtime. So it's really, really simple. It's really, really similar as a virtual machine. And the reason why it cannot get the executable and modify it in a static way, so you get the executable, your file.exe, you use some tool, and you get another executable, which is a, let's say, instrumented executable. You cannot do that. And the reason for that is that because you are adding new instructions. And this is usually a complicated thing to do, to add or remove instructions from an existing executable. Of course, it can work at several levels. It can work usually at instruction basis, but also at basic block or even function basis. So you can say, no, I want to look at the whole program just by looking at the functions, or maybe you want the basic blocks. Basic blocks is just a bunch of instructions. So what does industry professionals use binary instrumentation for? So far, I've seen a lot of industries using this, but they usually use binary instrumentation for performance evaluation and CPU emulation. For example, if you are, well, this is the case for Valgrind. For Valgrind, we have a cache simulator, so we feed Valgrind with our executable. Valgrind starts adding a lot of instructions in there, and every single time we access the memory, the CPU memory, what it does is it annotates that access, and it simulates a cache hierarchy. So you can get a lot of data like the hit rate of the cache. You can simulate like L1, L2, L3 hierarchies, whatever you want. And as I already said, you can use it to do tracing and profiling, which basically you log every single thing you do. And with that information, you can, for example, find how many memory accesses you do, which memory accesses are more used and which are not used at all, many other things. But we are going to use it for hacking purposes, let's say. OK, how can we use that for doing reverse engineering or hacking in general? Because there are a lot of potential in those tools, which no one, well, in the last 2 or 3 years, many people started looking at dynamic binary instrumentation, but previously than those years, I think that many people know about those tools or techniques. So one thing is that we can somehow replace the debugger, because debuggers are usually simple in the sense that they are only used to show information to the reverse engineer. But we can use that, for example, for create complexing conditional breakpoints. This is, we can say the tool, every single time you met a condition, but a huge condition, like, I don't know, you can do it at a higher level. For example, every single time you receive a parameter which is equal to this expression, and you counted like 3 passes through this function, you have to stop the program. And this is a thing that typically using debuggers, it's kind of complicated to do. You have to use the scripting languages, for example, but it's tricky to do. And another funny thing is that debuggers usually do stateless conditions. So a condition doesn't have any state. When the condition is met, it triggers the breakpoint, but it doesn't retain any state across evaluations. So we can add our own memory and save that like a state machine. So we can say, we want to stop in that function whenever this function with this condition is met, but only 1 time out of 10, for example. That would be a simple example. And for tracing and logging, it's really interesting. I mean, a lot of debuggers have already tracing capabilities, but we can go a little farther than what they are already doing. And the most interesting thing, which hopefully I'll show you in the demo, is that we can modify the application behavior. This is a thing that debuggers can do, but they are somehow limited to what they can really do. So my idea was, I'm trying to reverse engineer a software piece, I don't know, a browser, some application, And I don't want to read a lot of machine code because it was generated by a compiler. The compiler does a lot of optimizations. I don't want to follow the whole thing, like thousands and thousands of pages. I want to think like if I was the creator of the application. So if I was the creator of the application, how would I implemented this specific feature? And if you think like the guy who actually wrote the source code, you can deduce how the behavior of the program and the machine code will look like. And I said, OK, I want to work on a function basis. I don't want to really look at the disassembly, because it's really difficult to understand what disassembly does for a machine, at least. But I want to usually look at function calls, because usually the flow of calling functions, it's more interesting than the functions themselves. So I said, OK, I'm going to look for relevant functions. Let's say we'll see what a relevant function is, or we define it. And I'll use a complex breakpoints. So whenever I spot a function, I will evaluate some conditions and say, this function, it looks interesting for what I'm looking, or it doesn't look interesting, so I just discard it. And the thing is that we can look at the stack or the memory of the program, so we can do whatever we want. Every single time we see a function, we can analyze everything that is happening there. And of course, at the beginning, you write a very simplistic approach. So you have to actually log information to see what happens in there. And then you can refine your search. So it's very important to log everything you do. But with that approach, you can discard like 90% of the source code, well, of the machine code, and just get to the meat of the program, or to the meat of the thing you are looking for, which is usually, I mean, if you are hacking a program, you will usually look for the protection, for example. So instead of using pin, well, actually I started using pin as the binary instrumentation tool, but I just got bored of pin. It used to crash a lot with I was using a couple of big pieces of software, like browsers, and it used to crash a lot. So I just said, OK, I will write my own tool because I can. And I call it spin because it's like static pin. It's a static version of pin, a really, really simplified version of binary instrumentation tool. And spin is only capable of doing few things, but it does them really well. So what it does is it's a tool which runs in the application memory space. So it's hidden in the, well, hidden, yeah. It's injected in the software we want to analyze, like a DLL, something like this. So it can access all the information it wants about the software it is analyzing. It doesn't have to do any kind of inter-process communication, so it's inside the actual software. It allows us to see any kind of function call and analyze it, so we can step on any single function call and see all the information behind, which is hidden there. And well, actually, as I said, we can modify the behavior of the program. And the first thing I implemented, which is a really simple one, but very, very effective, is modifying the return values of the functions. Because usually, well, in the current software developing paradigm, you usually you do like, for example, object.get whatever parameter you want to get, object.set whatever parameter you want to set. So it usually use out of functions, like small functions which do a small computation and return a value. So I think it's a good approach to work with return values. And the most important thing is that it relies on compilers respecting the calling conventions. So if you try to use this tool with, let's say, I don't know, a weird C compiler or any kind of obfuscated software, it probably won't work. But as 99% of software, it's not obfuscated, or it can be de-obfuscated previously to using this tool, I think we are OK. So the thing is that, as I said, spin is, the S stands for static. So my idea was, instead of writing the whole virtual machine code unit in order to do binary instrumentation, I will just go for the basic thing. So the thing is, if you add or remove any instructions in a basic block, you'll have to relocate the whole program. Okay? You will have to as you have removed some offsets there, you will have to say, okay, now all the jumps, all the calls, all the offsets are wrong. I have to remap all these things. And as we don't have the compiler relocation information, I mean, if we have the source code, we don't want to use this tool. But if we don't have the source code, we probably don't have also the relocation information. So in my case, I said, okay, as I don't want to perform any kind of virtual machine or relocating stuff, I will just go for the most easy and straightforward thing I can do, which is every single time I see a call instruction, I only support the call immediate, which is a 5-byte instruction. Every single time I see this call, I will just patch the call with a different address. And this is an address which points to a place which I control. I have some function put in this address. This way, the instrumentation is completely static. I don't have to relocate anything, and it usually works out of the box. So I don't have to do any smart things. It's as dumb as it sounds. But the thing is that it works really well. And the principle of injecting the program, as I said, is just like a regular DLL. So I just get the source code of my, well, the machine code of my tool. I inject that in the application space. Well, I think we'll see better in this example. So this is the target application. And what I do is I inject a DLL inside the address space. And well, in order to inject that and do some other things necessary to inject the DLL, I have to use a executable, which is called spin. And once the DLL is injected in the address space, it starts modifying the application or even the library's DLL. So it can access to all the machine code it wants. And a good thing is that we can choose which parts of the application we want to patch, because usually we want to patch like Microsoft or system DLLs. There's nothing interesting in there, and we can just drop those hooks, and the program will run faster. I think I have a drawing here. Yeah, this is how the thing works. So there you see that would stand for a basic block of the original software. That would be a piece of the original software. We see a call function, and as I said, we patch. We remove the immediate there and put our own immediate. So whenever the application reaches that point, it jumps to a control piece of software we wrote. And in there, what it happens is that we do a global matrix, because it's the most easy way to implement this. So we just do a matrix. Then we save the context. So the program doesn't even know that it's being hooked. So it's like hooking a telephone. The people which are talking in that line don't know that they are being hooked. And then we call to the user callback, which is a function which has the meat of the thing. So there, in this function, we put a lot of source. Well, it's usually a fairly simple code, which analyzes the function, does a lot of, for example, it saves some state, it can modify the return value, whatever. And after we do all these things, we return to the matrix, like the glue code, which is responsible to undo what the first glue code was doing, which is it really lookups for the original function the program wanted to call. It restores the context, and it jumps to the function that the program originally wanted to call. So the program thinks that he just went from here to here, but actually you are doing all this. And this way you can steal a lot of information of that program. And this is automatic, so you don't have to like opening a debugger, going step by step, and saying, oh man, look, this function has these parameters, and this looks interesting. It's all automatically done. So let's go for the demo. Oh, actually, that was an animated GIF. It did like this. Anyway, I'll try to do the demo. As this is not my laptop, it won't probably work, but let's try. Oh, shit. Bah, okay. Okay, what I'm going to do is install a nice piece of software, which is called WinZip Jar. You guys translate for me, please. I'm not that good with German. Okay, yes, next. Sorry for installing shit in your computer. So I just installed WinZip. Ah, it's in English, thank God. Okay, now if I open WinZip, it will ask for the license, I think. Where's the zeta in this keyboard? My God. Yeah, no, it's okay. The keyboard layout is really, really weird. So when I open WinZip, I see this, okay? And this is asking for the registration code, okay? So now, if we go here, we put our name and the serial. So a good reverse engineer would disassemble the whole WinZip and say, I found the function which checks the serial, whether it is good or not. But we can use a tool to automatically do that. So the tool, let me load it. Okay, so here. Okay, here we have a spin. Well, it's impossible that you guys are able to see that, but there's a spin.x program in this folder and a tool DLL program. So what we do now is we call a spin.x. Then we have to introduce the process ID of the program. I don't know how to. Oh. This is really funny, using someone's laptop. Oh, perfect. So now I want to see the process ID of WinZip. Optionen. Fuck. Ah, thank you. Which is the process? Ah, yeah, that's in English. Where we have now the process ID. So let's look for WinZip. It's here. It's 3668. Okay. Ah, yeah. We add the. Well, we first call spin.exe, then we put the process ID, and then we put actually the main name, which is WinZip32, WinZip32.exe, and then we press enter. Ooh, that was fast, and hope it worked. Okay, now I enter a hard-code username and password. This was in the source code, which I do not have here, and hopefully it worked. Wow, we just registered WinZip. Ta-da! If I open it again, it just asks for the license again. So, yeah, it's here. So it keeps asking for the license because actually the modification was done during runtime. So it just hot patched the program. So what the source was doing, the source was assuming. Let me open the slides again. Sorry. Where's my mouse? Where? Here. Sorry, guys. Using someone else's laptop is a pain in the ass. But I'm cool with this. So what we just saw is that what we are doing is we are doing every single function in the executable, okay? And we are trying to think like if we were the developer of WinZip, which, maybe they are smart guys, but I don't know. So we are assuming that WinZip is, what it's doing is it is generating the serial, the good one, the one which we are supposed to introduce in the box, and it's also getting our serial, and it is comparing both serials. So it's using something like an str compare function, and it checks whether the two serials are equal, and in case they are not equal, it prompts as an error, and in case it is equal, it just says, okay, you're just registered WinZip. And what we are doing is we are looking for an strcmp-like function. So it's a function which has at least two parameters. We don't know more or less where they are, because maybe it has like 4 parameters, and the 2 last parameters are the strings, but something like this. We're looking for 2 parameters. Those parameters have to be like a nasty string, and those parameters have to meet some conditions. The first or the second one of them must be the serial we just introduced in the box, and the other one has to be like the good one. We don't know the original serial for that username, and it wouldn't be fair to assume that we know the serial name. But the condition I just wrote is it has to be an 8 character string. So it looks for every single function during runtime. So each time the function is called, it analyzes the stack and says, is it the right function I want to look for? Yes or no? And in case it matches the conditions, what it does is modifies the return value of the function. Basically, it nullifies the function. It doesn't call the actual strcmp, but it calls to a function which just says return 0. I mean, return that both the strings are equal. And actually, I am also logging the information in some log file, which is really useful in order to debug what happened there. And finally, I'm actuating. I mean, I just said it. I'm just modifying on the fly the return value of the function. And this is a good way to do that because, well, the ultimate way to do is to just log the information, get the IP, and then go with a debugger there and patch the executable forever. But this is a hot patch. So you've probably seen a lot of video games with patches because you don't buy all the games. I know it. And probably you'll find some patches which don't patch the original executable because it usually checks itself, but it hot patches the executable in memory. And there are a lot of other demo which I'm not able to do. Maybe I'll just upload a YouTube video and send you the video so you can enjoy that at your home. And the 2 demos, well, one of them, it's really complicated to do with my laptop, and the other one is in the other laptop. So the first one, it's a demonstration which basically I try to do more complicated things. I use a C++ program which has classes. It uses the STL library. And we have a problem there because a C program is really, really simple. But when C++ appears, there's a lot of different calling conventions. Microsoft has its own calling convention. GCC has the standard calling convention. So you have to, before using a spin, or either you create a full-blown function checking which cares about every single compiler, or you look at which compiler is using the program. So this is one point. And the other point is that we can de-instrument functions. This is when we are analyzing the call functions, we can say, I found this function, and this doesn't look interesting. And I found this function many times. So what I want to do is not analyze this function anymore. I want to revert the patch I did to the call function. This is really interesting because when you analyze a big software, in my example, I use a browser, Opera. Basically, when you open Opera with my tool, it's impossible to use. You click on new tab, and it takes like 2 minutes to open a new tab. So if you add a condition which is able to determine whether a function is interesting or not, you can reverse the patch, and it's way faster. I mean, you don't even notice that the program is being debugged or hooked in this way. And well, many other stuff can be done, like looking for pattern across calls, but I didn't really look into that. I just did 3 proof of concepts just to make the presentation. And in this example, what I did is I chose a program, as I said, a C++ program. It's a nice program to brew your own beer. And this program has a serial protection, and it's really easy to crack it because you only have to check whether the string it matches the serial, and then you have to make the string return a non-zero value. In order to do so, you have to be careful because as it's using an std string, it's not that straightforward. You have to load a pointer in a structure, in a class, and it's a little bit tricky, but it can be done, and it's better than using a debugger because this is a really complex condition. And probably, in order to implement this in a debugger, you will have to use scripting languages. And this was the demo I wanted to show you, but as my laptop decided not to work today, I'll explain it. Basically, I was doing a form grabber for all the browsers, and Opera kept resisting. So I said, you'll see. And I picked a fairly simple condition. I said, every single time you reach a function which has at least one parameter, which is a pointer, it has to be a pointer, and this pointer points to some post or get request, you lock that into a file. And in case you see a function which only takes like integer values or pointers to non-data areas, you just drop that function and do not look at it anymore. And using this simple tool, it's like 10 lines of C code. Using this simple snippet of code, you could log every single post or get transaction, even in SSL mode. So the demonstration, it was like just a SSL website, an HTTPS website. You put in your password and serial, and you press OK. And what it happened is that it logged all your credentials in the file. So the idea is that even if you don't are able to hook it manually, you can use the tool to do so. And the reason for using a tool like this is that it's kind of intelligent, because I mean the source that you use to get the password, it's in a high-level specification. So if you change the version of the browser, or even if you change the browser, it should, well, depending on the compiler, of course, and these kind of things, it should still work. So we are able to get information from inside the program, even if the program has slightly changed, because all the functions are still doing the same. They have the same parameters. They just changed some small things or the position in the binary, but they are still doing the same. So as long as they have the same behavior, we can spot them. And finally, I wanted to get some conclusions here. So in my opinion, I think that we can apply some automatical reverse engineering methodologies for sure. I mean, it's definitely doable. I've just done 3 proof of concepts, and I think that I can extend that into more meat. And it's smart enough that it can be used in production. So with just one tool, I mean, it is not a really complicated tool. It's like 1,000 or 2,000 lines of code. With just this simple tool, I can more or less extract all the credentials for all the browsers and some really simple programs like Messenger or Google Talk. So it would be definitely doable as more tool that, like in a malware or whatever you might think about, you could use this tool and you don't care anymore about versions. So whenever they update the program, it still works because it is not relying on the original executable. Usually, if you know, the game's patches usually do an MD5 checksum of the file, and in case you don't have exactly the same version of the executable, they refuse to patch the program because the patcher doesn't understand the program. It just knows which byte has to overwrite. So with this kind of patching, which is a hot patching, you can do whatever you want. I mean, you can patch almost everything as long as you put some intelligence in the tool. But of course, we have some limits. The tool is not perfect, but it works. Pin can say that. It's not really suited for API hooking because for API hooking, you usually use call tables, and the way we implemented this is not working with this kind of calls. And of course, if the executable is protected or obfuscated, it definitely won't work. But I mean, in the end, I just built a nice browser form grabber for me, so I'll got you all your passwords. And this is it. Thank you for hearing me, and I hope you are not bored.
So, are there any questions?
Easy questions.
Hi. Do you have the source code to show us for the WinZip hook?
Yeah, in my laptop. Well, right. If you want, I can send it by a link to Pastebin in Twitter or something like this, so you can see it.
And each time that you want to change that source code, the hook, you need to recompile spin in order to then rehook the executable?
You mean if you want to change the conditions?
Yeah.
Yeah, well, you actually only have to compile the DLL, which goes with pin. I usually compile both of them because I'm lazy using writing make files, but yeah, you only have to change the DLL.
Mm-hmm. Does this work with signed executables?
Sorry?
With signed executables.
Signed executables? Does that even exist?
Yeah.
I don't know. I just check with regular executables.
All right.
Probably with, well, it's doing patching in the memory, so maybe it should work. I mean, if you saw, I just applied the hook while WinZip was running. So I do not launch WinZip and then modify it in order to execute it. I just hot patch it during its execution. You can do, I mean, it has two modes of working. So probably the hot patching one should work with signed executables. I'm not sure, I'm just speculating.
Okay, so.
You said your tool wouldn't work if the code is obfuscated. So, but if it's obfuscated, it's only a challenge between you trying to mimic the obfuscation or the obfuscator mimic his obfuscation in his compiler. So how would you rate this challenge? So. Yeah,
you're right. I mean, it depends on the kind of the type of obfuscation. If it's just obfuscated at function level, so if the obfuscator just takes a function and adds a lot of sheet instructions there so you cannot understand the source, then it should work because the calling convention is still respected. But if they change the calling convention, which I don't think many people will do because then you maybe have to write your own or modify an existing compiler. But as long as you change the calling convention, it doesn't work. Does that answer your question? Yeah, of course, you can change it, but I mean, if you this tool has like some support for the most basic calling conventions, so yeah, I should have to add a lot of code in order to support the obfuscation. I don't think I'm following you. Maybe we can take that offline if you want.
Before going for this route, have you considered going for vtrace or something like that? For instrumentation?
I mean, you mean tracing the application?
No, vtrace is a Python framework for actually. You can use complex breakpoint and so on, and it works. Mainly, you have the same result. Is I think a bit more powerful because it's also cross architecture. You consider that?
I didn't consider that, but it should work. I mean, it probably would work.
Yeah. Okay.
So, any questions left? Okay.
Come on, guys. Easy questions, please.
What about as far as license verification? That was a visible license verification process. What about a dormant one? I mean, the perspective is like the verification only works in like Michelangelo's birthday. It isn't consistent. How would you use the same method to identify it?
You mean when you don't enter an actual serial, but the check is done in some other way, like a file or?
Well, it's not, I think the best definition is an inconsistent DRM validation. It's not something that's a normal flow. It may or may not happen based on certain conditions, such as WinZip may re-verify the license when the CPU temperatures jumps to whatever.
Well, actually, just in this particular case, in WinZip case, it keeps checking the license, but it's so dumb that it calls the same function. So, so the first time it says, hey, it's okay, you managed to buy WinZip, and when you click I accept the license, it checks again. And I think it checks every single time you open the menu, because in the About option, well, there's actually an option which is register WinZip. So every single time you click in the menu, it checks whether it is registered or not. So it keeps checking every time. It has like more than one flow to check whether it is registered or not.
So eventually you would have to recognize the dormant method.
What?
So eventually to use such a process, you will need to eventually locate the dormant method that performs the validation?
Mm-hmm.
I mean, in WinZip's case, it calls the same method over and over, but to identify a dormant method, you would have to identify.
Yeah, but as it is, as the tool is based in, I mean, the tool is using the call, the calling action, not the function itself. So every single time you call a function, even from different points, or even the function is different, as long as it respects and behaves the same, I mean, if the function behaves the same way, you are just able to do the same. Okay. So it all depends on the behavior. As you say, if you have like two flavors of the check serial, one checks the serial in one way and the other in another way, it will probably fail. And actually, WinZip has like two different checks. The first check, I think it checks whether your serial is from an old version, and the other one checks whether the serial is from the current version. So, but yeah, you mean it's difficult to do this consistent.
So I think we'll have one last question as we're a bit over time now, but yeah.
Can you elaborate shortly why it's not possible to use for API hooking?
Well, as I said, usually API hooking, well, usually, it uses an indirect call. So it calls using a register value, and I'm not patching those functions because patching an indirect call is a 2-byte opcode. So I would need more than 2 bytes in order to handle my patching. So it doesn't work right now. I mean, it's doable. It's definitely doable, but right now the tool doesn't support this. And if you want to do API hooking, you have plenty of tools which do that, and they are easier to use.
Okay, so now I think we'll close the question and answer session here, but I think he will be available.
Sorry?
I think you will be available outside or during the meal or something.
I won't run away.
So, yes. We now have the lunch break, if I remember correctly. So.